everyone. I welcome you all to yet another day of our amazing boot camp. I hope you all are very much excited for today's session, and also it's going to be a very amazing one because in the past 2 days we were talking about the fundamentals. We were talking about how you can get start your journey, and we were talking about a lot of stuff in artificial intelligence. And today it's the day three, and so we would be talking about on some other functionalities and the fundamentals we would be covering. So I hope you are very much excited, and also if you haven't watched, you can just have a look to our previous days, day one and day two, okay, which are present. You can easily find that, and just work on that so that you can have a better understanding of the today's session. Okay, so with that note, we again have Santosh. He would be taking you through the whole journey, and also he would be taking you through for the day three. And currently, he's working, right? So in that case, he has amazing experience, and it's been a great time that he has been contributing to Azure developer community. So hi, Santosh, how are you? You are on mute.
Um,
Yeah.
Okay, can you hear me now? Okay, great. So I think today is the day three, and we'll see a demo of how things are. So I'll show you a pipeline which is already there, and then we'll discuss on that. First, we'll cover up the last bit of the portion. That is some NLP part. So we have seen image and other things. So we'll cover up NLP as well, so that you get a full idea of what everything is, and then we'll go to the demo.
Perfect. So now the
So
stage is all yours. You can just call me up anytime. Okay. Yeah.
sure, great. So today, as we have discussed on day one and day two, so day one is more of basics, and we have gone through a couple of types of machine learning models that you can create. We went through classification, we went through clustering, and then we went through regression. And day two, this is a quick recap for if you are joining late or if you have joined only this session. So day three would be more for the NLP side and what you can do with text and characters. Day two, we have seen what an image is and what are the things that you can do with an image and what exactly an image processing or an image analyzing process does, and as well as we have also seen how the image analysis progress through the history. So we have seen just image classification, and we went all the way up to generating a text based or a description for an image. So that is how we have come across. And today we would cover up the NLP part, and then we will go on a demo so that you will get a better understanding of building models without even writing single line of code. With it is again with Azure Machine Learning Studio Designer. So we'll talk about that, and then we'll see what are the things that you can do, and you can also try it out if you have again the student subscription if you have it, or if you are a registered student in any of the universities, you can try with your student ID, that is your student email address. It might be Outlook or a Gmail. You can definitely the extensions should be .edu obviously. So you can try with that and get a $100 credit for using Azure. It is for 1 year. So after that, you would definitely have to get pay as you go subscription. With that said, we would start with today's topic. I think it went too far. So what we will see today is the another phase of machine learning, right? So we have seen image as a source of what you can do with what you can accomplish with machine learning models. And this time we would see how NLP or processing text is one of the other streams of how an AI engineer would go about. Another interesting part of NLP is that most of the places where you see the NLP is evolving a lot these days. The problem or the key advantage would be is you can replace someone very easily, right? So if you have a question, right, So let's say if the Q&A, you keep asking the same question, maybe to a site, let's say if there is a site and then you want to get the event venue or the dates or maybe the speaker name or maybe what is the session I would like, right? So this could be another hackathon idea. So I'm just spreading it out. So let's say if there is an event from Azure developer community and there are 5 tracks or 3 tracks and there are 10 speakers, and let's say you create a bot and then you give what are what are your interests. It has a keywords, and what the bot can do is go through the site and then give you the best sessions that you can attend. You can also include what level that you're looking for, beginner, intermediate, expert. So you can also suggest you something based on that. So this is another idea that this is my second idea that I have gave out. So these are some things that you can use, right? So it is a real you're solving something. Many people have asked me for suggestions on which session to attend, right? So they don't know exactly what they need. So it is obviously you need a human to do it, but with some kind of a smartness in AI, you can definitely try out something of that sort. Since the data set is static, you know what are the speakers and what are their topics and what is their description of their talk. So obviously, you can try out something of that sort where you would obviously have some kind of a extra knowledge on the platform itself. So if you're organizing something maybe for your university, then obviously try this out so that you can plug it in and then people can really use it. So let's say, or you don't have to even plug it as a bot. You can just directly integrate that into your site itself, and then just have a tag. And these are the things I'm interested on. These are the keywords that I wanted to see, and this is my level of learning, or this is the level that I understand about AI, and so the bot can give you suggestions based on that. So that would be another idea, great idea that I haven't seen anywhere. So obviously, it is nobody's working on that. So definitely, you can start working with that. Cool. So we'll see text analysis. So the second part we will talk about is again a demo. So that is for sure. I'll show you the pipeline which you can use. I do have a pipeline already, but we'll create a new one and see how the compute looks like. What is the data set that we are using, and other stuff. Cool. So introduction. I don't think there is any. So these are some of the basic stuff that we have. So text analysis, entity recognition. So the second part is interesting, right? So entity recognition is where you have bunch of, let's say you are talking, and then we pick up objects or items or places or maybe food items. If you're talking about maybe, let's say you want to go to a place and then you're talking that to your friend or you're talking about that to a larger audience, and what you can do is you can have that recognized, convert the speech into text, and then you can do an entity recognition where it would pick out the most used words by the speaker, or there could be a place where you can find what the speaker is interested in, or what is his favorite food or color, or you can do a lot of things when you have the entities recognized, right? So when you have that bunch of words that he has used frequently, then that you can use to do further processing down the line and then come up with something. So that could be one of the advantages of it. And the second part is sentiment analysis here for a long time. So you have seen tweets, you use Reddit, uh, we have sentiment attached to it. So let's say if someone is happy, they have won something, they have achieved something, so they are happy. And you can also check how many happy tweets have you been tagged to, or how many sad tweets have you been tagged to, how many sarcastic tweets have you been tagged to. So those are some of the ideas that you can use sentiment analysis for. And speech recognition and synthesis, it's pretty much the initial step of what we talked about entity recognition. So entity recognition, we can just do it in text. So let's say you already have the text. Let's say you're going to read a book, and then I just don't want to read the entire book of 500 pages just to get some insight that I already know, right? That is completely it doesn't need a human to read through all the 500 pages just to find something he already know. right? What you can do is you can run an NLP bot and then pick up what are the sentences or the places where the author stresses something the most, and then extract those sentences instead of reading the entire book. So that is one way of seeing it. But speech recognition is where the first idea where someone is speaking to you, or if you're attending a conference and then you record it and then you come home, or you have a live recognition and then you keep on processing it and then you come to a conclusion. So that is another aspect of how you can talk about speech recognition. Good. Machine translation is more of nowadays, people, or at least most of the websites have different languages, so they have options to switch language between the same site, where you can choose between the local language, regional languages. We have support for that. Or if you want to go for international, then Russian, Italian, or whatever the language that people speak. uh, you know the region wise they split it, and then that is one of the ways that you can reach more people, since not everybody understands English. Obviously now everybody knows it, or at least where places are still people are struggling to understand, and they understand the normal way of talking, and there are people who needs text description of things so that they can better understand stuff. So that is one place that you would use the translation work. And the language modeling is another place where we would have you respond to things. So now, if you're I'm not sure if how many of you seen this, but somewhere in 2018 or 19 there was this show where someone talked about having to call a restaurant and reserve a seat. So that is a simple thing to do. But if you try to automate that, right, what you would do is you would suggest one time, and on this particular day they'll say on a Friday or a Saturday evening at 7 p.m. So that would be the table, and then you would have a table for two people. So that is obviously that you need. And you can ask a bot to do it. What it will do is it will call a restaurant, and then it will try for 7 p.m. If you don't get it, you need a second option. So it would be talking as a robotic. You will get the feel of you're not talking to a human, of course, since it won't have that intonation, or it would just talk on the same pitch every time. So there is no pitch variation that as humans we do. Just by hearing me out, if I'm smiling or not. So that is one way to find out. But there is no way that a normal bot which talks in the same pitch, you won't recognize that when you see a bot which does that. So that is one place where language is still gonna be a barrier. But it is, you can ask questions to it. So where can I uh, get the closest gas station, or where can I find the best restaurant for some sushi, or whatever you prefer to have. So that is one place where you could find out different stuff. Another piece is where modeling part comes when you need something really specific or niche, or you can go broader as well. So you don't have to focus on one thing. Let's say there's an map navigation system, and then you ask a question, which is the shortest route to go to a movie, or what is the shortest way to reach this address. So that could be one of the modeling that you can do. It understands that, and then it converts that into something that you need. So it has to understand what you need exactly, from the perspective of if you want to drive to a place, and then it has to find the shortest route and everything, and then it has to give you an output which you could relate to. So it can't just give you, if you ask for a direction, it can't say uh, go straight and take a right. So it has to guide you step by step in the process of what or how it can be done, so that you achieve the right place, or you go to the right place in the first place. Great. So this is the cognitive service that we were talking about. There are a lot of services inside that. So this is only for the text part. So what are the things that you can do with text? So this is another important service that I have been using a lot these days, where you create one service. So there's another introduction that I didn't know of, where you can create just one particular piece instead of having to on the cognitive services. You can just create, if you want to do only your requirement is you just need to translate one language to another and back and forth, right? What you can do is you can just create text translation service instead of opting for the entire one. Right. So if you're just using that, then why can't you just have that one thing instead of having everything together? So that is one way of looking at it. But again, that is one place that I would see that cognitive service has a lot of advantage over using everything at a time. But if you need all the things, let's say I'm not sure what I'm going to do, but I need all these different types of services, I may use or I may not use, but I think it is good. I would have all these in the plate instead of having just one. So in that scenario, I would recommend that you go with all the things if you are not clear of what you're trying to do or what you're trying to build. So that is most for the initial one. So so analysis, I think you would understand the phase and what exactly it is. So again, what are the things that we saw in the first slide? The language recognition, of course, the first one. So it is just a text, and it is just some UTF-8 code. So for computer, it is just another piece of code that it has to translate to describe maybe H, right? H is somewhere around, or A is of course 65. So that is one thing that is ASCII though, but UTF-8 does another value, maybe not sure of the number exactly, but it is just values, right? So I'm trying to say is it is just numeric values that the computer knows. It doesn't know that whether what language it is. So what we try to do is we try to bracket it out. So if these are the codes, then this is the language. So that is one part where you would see this particular model happening, or how it detects the language in the first place, even if you type. So there are this particular phrase where you type regional language, uh, words or maybe phrases in English, right? So that is a bit tricky, but it has to understand the language and the tone of it, to not exactly the tone, but have you put it out to understand whether it is English, or you're just typing it out in English characters instead of directly taking out the language itself. Great. So in this text, it is pretty clear that someone is happier since they went to France. So obviously they would be happier for sure. And the first bit that we saw with entity recognition. So as I said, it could be a place, it could be a food item name, or it could be a shopping list where you have a bunch of things that you want to buy: milk, bread, eggs. It could be anything where it means something. So it could be a noun, probably, maybe a proper noun for sure. So it could be anything which makes sense, or that sentence wouldn't make sense if that word is not there. Maybe you can consider it of that sort. But obviously, the entity is nothing but where it gives you a complete meaning to a sentence. So you can call that way, or either it gives you some completion to anything. So you can consider it in that way. So I had a wonderful vacation. Also gives sense. No, you don't have to say which where you went. The next question someone asked you was where. Right? So I had a wonderful vacation. Where you went, or how was it? Now, you should definitely say where you went, or you should at least explain your experience or what is the journey that you have went through, so that that other person who is asking you could also feel it and then see how what exactly or where exactly you went. This part is a bit tricky. Speech is we can't simulate anything in speech, but the way that speech is converted is a bit trickier than how you do with text. So we don't. There are like a lot of devices which record things, right? So again, we have a service in Azure to convert from speech to text and text to speech. So we do it in batches again. So what we do is you continuously talk, but what happens really is you chunk the time slices, right? The time would be sliced for 100 milliseconds. I'm going to record this, and for the next 100 milliseconds, I will record that, but I won't send, and then record I won't send. So there could be a delay. So whenever you see some live streams, it is a bit on the delay side when you see it on live. So it doesn't, nothing is real time, right? So what you do is you have something, but there are few services which is real time where you click and then action is performed. But in this particular model where you, uh, at least for the speech recognition or the recognition, you record something with your through your microphone. What I have seen or what I have done with my personal experience is where you have time slices and then you process it and then you give the output. It is the same for any most of the services that are out there, for other services if you take other than Azure. But Azure does it in this way, or there is another live recorder thing. But again, it has to internally slice it. It can't send. No, it has to wait, right? So whenever you talk something, it has to recognize it and then it has to print it out. It is not just you record things and after 1 hour you would get the entire transcript and nobody is asking for that. We need something live transcript. Whenever he talks, it has to be like whenever he has to complete the sentence, the text should also have been completed. The processing has to be that fast so that it is more accurate. So the only problem is you have to get it accurate and faster. So it should be snappier that whenever he completes a sentence, it should at least be completed within 200 milliseconds after the speaker has uttered a word. So obviously that needs a lot of training with the model to get it more accurate. But again, it totally depends on the environment. So if the environment is too noisy, then you need a better noise cancellation technique first as a first layer. Then you have to go to the second layer uh, where you can exactly do the recognition of the text, and then you can put it, make it into a word, and then you can, and then you would at the finally you will put out the sentence, and then again the sentence comes back with phrases. Sometimes when you see the live transcription, right? So what you get is you get the complete. You won't get the complete sentence. You'll get the phrase, and then what happens is when the sentence is completed, it recognizes a complete meaning out of it, and then what it does is it kind of rephrases things, right? It does the correction of punctuation and other things. So it is one place where you would see on how it works. So that is one of the places that I have really seen on how exactly it looks like. So that is one place that you can definitely see for yourself when you attend a call on Teams. Maybe that could be a scenario where it gives you the phrase by phrase or word by word, and then it rephrases the entire sentence or it does the punctuations right once the sentence is completed and the speaker moves to the next one, so that it is more cleaner to look. So what happens here is you know take time slice, 100 milliseconds, process it, give the output. So another 100 or 200 milliseconds would have passed by then when once you process a particular word and come out. And then what we are trying to do is again process that particular word. You just give it, it is like an intermediate result. It is not like a final thing, but for the sake of just showing the user that something is happening or the speaker is saying something. So you would get word by word translation first, or at least some meaning to it. And then once the sentence is completed, once the entire sentence is completed and the speaker says, okay, this is something that is totally working. Right? So I have been to France and it was really great. So once you say great, and then the sentence is completed, and then it rephrases stuff so that it looks good, and it also makes sure that it is more accurate than what the intermediate result was. So that is one place where you could definitely see what is happening. Great. So again, this is the another service that we talked about, translation work. So we know that this is so as you have seen, this is another evolution of how the translation is being done. So we did word by word translation, meaning if you say something, it directly gets that particular word and converts that particular word into the equivalent of another language, right? So in English, what we have is subject, verb, and object. So there are languages where the verb goes at the end, and then this object comes in after subject. So what happens is, you would have a mismatch, and the sentence won't go along with what exactly the phrase was. So when you go move the verb out of the context at the end, since we are having it in English, so we can't use any other language. But again, if you have that scenario where you have to use subject, object, and verb, where you have to do some other things other than word by word translation, right? So if you just move the word, uh, you know maybe if you just directly translate equivalent of the word, let's say you have four words and then you translate exact, so we know the equivalent of it. It is like a key value pair. You give this word, so this word means this in this language, we know that. So someone has entered it and someone has verified it, and this is the translation that has to be done. So what you do is you do a direct translation, you give it a key, and then you get a value back, and then that is it. So that is no longer existing. So whatever the translation that you do, you give a text or you do a speech as well, so it gets directly translated into that particular language and what exactly their sentencing structure or grammatical structure that they have. So that is one of the fascinating things, that if you see that what we have come across, as we saw in the image last time. So it is also another fascinating feature, or I would say another engineering marvel that it has been done. Great. So again, so this is another part. This is also interesting. So this is something that we have come up. Azure has come up with a lot these days, and it is a bit costlier though. So what you do is you have a workflow. So you. So let's say you want a restaurant to be booked at 7 p.m. So what you do is, so you don't have a table, so everything is full, and then what the tells you is that there is no reservation for 7 p.m. Would you have it another time? What you do is, again, uh, you have to respond back something, right? So what we do is we have bunch of if and else and conditionals where we check if something is right or not. So the user can be either okay with the decision that the bot made, or they can be unhappy with it. So what we do is we try to write conditions for both, or maybe there could be another condition where uh, they're not perfectly happy with it, but they're not like too much worried about the result, and they are like okayish, right? We say that a lot. So for those places where it is okayish, we need another condition maybe which says that if this is what the user wants, we could also present them with so let's say if the table is not there, or let's say if you have booked a table and then you get a message that this table is again reserved, there is some party happening at that same place, so they have to cancel all the bookings. They could also give you a discount for another time. So that is another flow, right? So you give another part where you tell that this is something that is happening, and you can translate that directly to something else. Cool. So just give me a sec. Cool. So what we were talking about is entity recognition and how the flow works. So it is not just happy or unhappy, yes or no, but we also have some intermediate states that we have to take care of when we are dealing with stuff, right? So it could be there are places where you don't have to take care of those stuff, but again, it is always good to have another example or another way or another approach to it. So this is another interesting thing that I told you. What if there are this scenario you have come up, you might have come across, right, where you uh, do text replies, right? So where you type something and then the bot responds with a static response, right? So hello and the name. So the name would be filled in when you enter the details, or if it knows your name, it just fills it out instead of saying hi or welcome or any other greetings that you might have configured. So the conversational part is making sure that you are more realistic, or the person that you're talking to, you are trying to mimic a human in at the end of the bargain. What you're trying to do is you are making a human work, or a work of a human that you're trying to you know do it in the right way, or you're trying to do it more efficiently instead of repeating the same thing over and over again. So what you do is you replace that with a bot, and then it doesn't it doesn't get tired of telling the same thing. So it doesn't have it doesn't get tired of anything. You give the work, then it keeps on doing until you give it power supply, and you have the backup, and you have the internet connectivity. So, so the part where the most place that you see is maybe when you're purchasing something and you want to inquire about your order or your purchase. That is when I have seen the most use of a bot. But otherwise, the first idea that I gave you at the start of the session, where you that is a real use case that I would like to see if someone is developing it. Maybe that could be really interesting to see, but maybe I would also try that out. But that is one real legitimate use case, at least that I could think of for this session, right? Where you can again, I would repeat it again if someone has joined late. So what you can do is you have, let's say, Azure developer communities, like in organizing a event. So Azure Days is something that I think they have covered most of the cities now by now. But let's say if next year we do the same thing, right? So next year we would come to all the cities again. So say we have 5 tracks or 3 tracks or 1 track, and you have 5 speakers. Let's say you want to choose between tracks. Let's say you have another commitment in the morning, so you can just only attend the tracks in the afternoon. You have 3 tracks or 2 tracks, so you're deciding how you choose between two if you are really new to something. When you start with Azure, like really new, you have never heard about cloud, or you have never heard about, or you have never worked on Azure. So obviously you would have heard about Azure or cloud by any means now. But if you're like new to cloud and what you're not sure on what type of sessions would help me to grow in cloud or to get an idea, so that could be a place where you just type in what you want. So let's say I want to learn about Azure from scratch and from the basics. What are the sessions that I can attend? So this is the sample template that you can use, and then the bot can give you suggestions. And another added feature is where the user also gives you the level. So it also, you can also get that from the entity recognition that I spoke about earlier, where you say from scratch means he or she is a beginner, right? So the person who is talking to it or who wants the answer, is a beginner or someone who doesn't have any knowledge at all. So you can also do that, or as the user manually how well they know, you can have uh, you know ask them to rank their knowledge on cloud from 1 to 5 or 1 to 10, and then decide on which sessions to prioritize for that particular person. Okay. So again, we talked about this on the first day. So responsibility principles, um, principles of AI is something that again we have. If you're like new, I'll just tell it in a brief what it is. So when you give out something, right? So you're not sure where it goes and where it is handled and who is handling it, and whether the data is destroyed or not, right? So once it goes out to the public or once it reaches the destination, you're not sure where it goes, right? So even uh, when the transact is end-to-end encrypted, your if you use HTTPS, it is encrypted in the transit. But again, once it reaches the destination, when the user or the server sees the request and how the data is handled and whether the data is removed as and when it is not in use. Let's say you're requesting for an order request or order inquiry, and you have a session of 10 minutes. So whether the data is cleared completely after the session or it is only for the user, is that particular session, the data has been cleared and we have a backup, or we store that information on when the user requested and which user requested, and all the data privacy issues start with that. But most companies are like transparent in nature. They say that this is the time that we keep, and this is the thing that we do once we are unable to fulfill your request, or when we are not using your data. So once you delete your account, you're not sure if whether the account is deleted or not in the first place. It is like nobody is using it, so it means that it has been deleted, or you could take it in any other way. But yeah, so that is one part that I would want to emphasize on. So for Azure, you could use the Q&A maker service that we have, and we also have Lucid. So those are the two services that you can use to make the so Q&A bot, or I would more call it as a chat bot in general. People are familiar with the term. So what you do is you send in a request, you get something in back. So you go back and forth until one says thank you, or they leave the chat, or it concludes. The conversation concludes. Right? So you ask for a request, and then you are satisfied with your response, and then you end the conversation right there. So again, this could be integrated with a lot of places. So you can build one bot, and then you can push that to multiple services, maybe your Outlook or your Teams. So there are some bots which you would come across in Teams probably, since it is more easier, or there are other platforms which has some similar service where you could request for a status. So you have been there in the group or the community for a long time, and you have responded to, or you have guided people around, and the bot can give you ratings on that, or there could be ranks, or there could be badges to be earned. So let's say if you help 10 people, or if you respond in this particular time frame, you would have a score or a point system where you would get accumulate points, and then you would earn badges. So that is one place that I would see is one of the places where you can use the bot service. So we would take up few questions until I swap the screens for the demo. So if there are any questions, feel free to drop it in the chat. So we would uh, see the demo part.
Thank you so much, Santosh, for amazing insights, and it was really, really great having you. And yeah, you all can just have a look to the AI fundamentals known properly. And yeah, that's all. Thank you so much for joining in.
No, I still have a demo to show them, or we are out of time.
Yes, can you please
No, I'm
come again?
just no, I'm just showing them a demo, or is it like? I think we are on time, right? Something like that. It is
Okay,
eight
well left. Okay,
forty-five.
let me just. Okay, just give me a second.
Okay, well I
Okay,
can see.
yeah, it's visible now. It's
Okay. So what we'll choose is the designer that we spoke about. So these are the previous runs that I did. So again, you can take out, you can directly do training and deployment from here. So you don't have to even write any piece of code. So then there's a new update to the UI, which I think I like, but I'm not sure. No, but pretty much the functionality is the same. It's only they might have increased the font, and they might have rounded the corners, obviously. So there is an auto save. I think I haven't seen this. That is why you have to like keep on checking what is happening. So these are the different stages, I guess. What we have over here is linear regression, and then we have the raw data, and then we split, and then clear on the missing values. So this is how you can drag and drop stuff. So you don't have to code anything. So what you do is you just need the data for sure. So whatever the data that you're trying to get. So this is a pricing data, I believe. Let's see what the data looks like. Okay, so this is the data that we have. So we have fuel type, the maker of the car, and the feature is, I think it is the price. So we, with all these details, the height, weight, length, wheelbase, engine location, wheel drive for wheel forward, convertible, with all these data, the number of doors. So we determined, I think it is the price column that we are trying to predict. So we'll see that. So in this particular, so I'll just walk you through what is happening in this pipeline. So this will give you an idea of what exactly we are trying to do. So we say all columns, excluding column names, normalize glosses. So we have 24 columns, I believe, or 26 it is. Okay, 26 it is. So we leave out one. So we have 25 now. So normalized losses has a lot of uh, values. I think it is most of not a number. So NAN is like not a number thing. So I think that is why we are leaving out this particular column. But there could be other reasons why we leave out a particular column. Unique value is just 51 and missing value is 41. Okay. So remove missing values. So this is another cleaning step that I talked about when you build a machine learning pipeline. So the starting part is where you clean the data and you do some feature engineering where you pick the feature. So that particular place needs someone with the knowledge of the technology in what you're dealing with. So let's say if someone knows about cars much, so they would be better at choosing the features that the car price, how the car price is determined. If you're not new to the, if you're not understanding the industry as much as the machine learning part or the coding stuff, it is really harder. So that is why more people won't be familiar with any industry, right? So if you're a fresher just coming out of college or wherever university that you've been through for your BTech. So what happens is they don't have the industry knowledge, or if you are from a different domain, let's say if someone is from a civil domain, and then there is a place where, let's say there's a flooring planning going on, and let's say if someone has completed BTech in civil, and then they come and do the machine learning work, and then they try to train the model or do the feature engineering part. They know best how many pillars for that level, the floor level needs. Right? So there would be more. They would have the industry knowledge that is required to choose which feature is important. It is also more important to understand the code and how you write the code and what data you normalize, how you normalize things, or which feature to remove and which feature to add is something would come only with the industry experience. You cannot get that just by training 100 different models. So that is one way where I see that your domain knowledge shines a lot than your technical stuff. So that is one part that I see that you should develop, right? Choose one industry or one particular domain that you want to work in, and then you can go from there. So the part that we saw on the first day, if you remember, we splitted the data into half or more than just half. So now what we do is we have 100% of data, meaning you have 100 records, and what we do is we take 70 for training and 30 for testing. So again, we have discussed that why we split it. So the way so it can be 80/20 as well. So it is totally up to the AI engineer who is building the model or the data scientist who is building the model itself to choose which data is best or which ratio is better. But again, it is totally experimentable, and then there's no hard cut rule that 50/50 is impossible, so nobody chooses that. So there's a threshold of 70/30, or you can go below 65, maybe 60 to 65. But I think below that, it is like the model won't be trained well since you are just throwing out all the data. So there are two different things that I would, it is more of a technical term, but just hear me out. So it is something called as overfitting and underfitting. So let's say you train. So this is another. I'll give you a simple analogy to kind of understand this. Right. So let's say if all the, so you might have taken a math class in your school days, right? Sixth or seventh grade, where you have some questions with answers at the back of every lesson, and then there are questions without answers, right? So the questions with answers are more than the questions or without answers, right? So that those would be your homework, and the classwork would be done by the teacher, if I'm not wrong. So the reason why we have that is the reason why we choose 70/30 split instead of having, you can't go below, but you wouldn't have the knowledge, right? So if the teacher is not, or if the school teacher is not able to explain all the scenarios, at least most of the scenarios, you wouldn't be able to solve your homework, correct? So the if you go below, let's say you have 10 sums to solve, and then so let's come back to the data scientist part, where he chooses to have only 50% of the data for training and 50 for testing. So what happens here is it goes to underfitting, where the model doesn't give you the results that you need. The accuracy is too low, and the model is not performing as you like. And if, let's say if he goes to 95 percentage, right? So he goes to 95 percentage and trains the model vigorously. So what happens is it goes to some term called as overfitting, where it kind of, the line graph that we saw, if you still remember it. So let's say if we don't want to draw a straight line, and then we there was a distance between the dots, right? So what we wanted to achieve in that regression part is the dots should be as much close as possible to the line, and we draw a line which is really close to all the dots, or at least most of the dots. So that is what we are trying to achieve. Let's say we don't have a straight line anymore, we have a zigzag line, and then we are trying to you know pass through all the points instead of just having uh, maybe a mean value, and then we draw a line based on that. So that is one of the scenarios where it is called overfitting. The problem with overfitting and underfitting is that overfitting would destroy the model as such, and underfitting is again you won't get the output as you need. So both are bad, and there should be a median place that you have to find to make sure that model is not performing too poor, or it is not too much excellent. So uh, so you can't achieve 100 percentage in model's accuracy. If you do, I have done it. So if you do it, it is wrong, and it won't work in all the scenarios, right? So there are different labels that you would train. For some labels, it would be 100%, but others it won't be. And it is the overfitting problem, where it shines in one place and it loses out in another. So we want an average, or we want to have a generic approach to it. So everywhere it should, for every class that you are trying to predict, it should be more or less similar, I would say. So that is what we are trying to achieve. So linear regression, how much weights that? So if you want to have what exactly it is, so again we see avoid overfitting. So that is what we are trying to avoid, and these are the terms and terminology that we would use. So these you can change it manually if you want to, or the code wise you can change it as well. So it is more easier to change it this way than to write a code for it. But again, it totally depends on what you are trying to do with it. So the lines that you see are the flow of the data. So this is the raw data that we have, and then we select what are the columns that we want, and then what we do is you do a cleaning, remove missing row values. So what values that you are removing, and what you're trying to do is we remove the entire row instead of, it doesn't make sense, right? So if the value that we need is not available, then of course we don't need the entire row. And then this is the interesting part, we split the data. So randomized split is where it shuffles stuff, rather than just taking first 70 records to a training and the last 30 to testing. It could be good for some cases, but always it is randomizing stuff doesn't make any difference. So we definitely do a randomizing part. So one part of the data goes to the training part, and the second one put for the scoring. So this is how it works. So you feed the model in. So this line is the model line, and then it says untrained model, and then this where you have the second data set which goes into the model itself, and then you start training. So it could take a while to train appropriately. So it totally depends on what kind of compute that you have. I don't have any compute as of now, I believe. So you need to select which compute instance that you want. So compute instance is the cheapest one. Compute cluster is multiple machines. An attached compute is a dedicated machine. So obviously you don't have to spin up anything. So you have to create a new one just to execute it. But you can do, if you want to really do it, then go with compute instance. And once you're done with it, please close it, or just kill the entire compute that you have created. So otherwise it costs a lot for the compute to run. So obviously it would terminate itself after some time, but it is better to do it yourself rather than waiting for it. Great. Back to where we started. So, if you have any questions, we could take this. This is the final day. So, if you have any questions, we could take it up, or else we are definitely good with what we did. And yeah, pretty much, I would again share the feedback link. I would definitely recommend. Feedback is something really important for anyone, and that is what I recommended yesterday. So obviously, that is something I would want everyone to do. It just takes 5 minutes. So yeah, so we'll wait for another 3 to 5 minutes for questions to come, or if there is any question, if there is no questions, then we are good to go.
Thank you so much, Santosh, for your time. It was really, really great having you. And yeah.
Yeah, I don't see any question. So yeah,
Like if you have any doubt, you can just ask him over the LinkedIn. I have already shared his LinkedIn ID over the calendars, so you can have a look into it and you can just ask him directly. Perfect. So with that note, thanks a lot everyone for joining in for this amazing day 3 of Microsoft Azure AI Fundamentals AI 900. We'll see you soon with some other sessions super soon. Thank you so much. Thank you, Santosh, again for joining in.
thank you. See you all. Bye.